6.5, the last section in our chapter is properties of special parallelograms. So our special parallelograms are rectangles, squares, and rhombus.
Yeah.
A rhombus. So the first one we are going to look at is a rhombus. It says if a parallelogram is a rhombus, then the diagonals are perpendicular. Oops. Having to use my finger, guys, sorry. Oh, you guys got to figure. This is how your guys' writing is.
That is not true, Miss May.
Hey, but now she's gonna waste more time.
I am.
Maybe Dylan.
Okay, you guys are wasting lots of time. Can we stop? Okay, right. Perpendicular. Okay. So the diagonals are perpendicular and bisect. Why is this not working? The opposite angle and all the sides are congruent. Okay, so a rhombus is a parallelogram, or if a parallelogram is a rhombus, then the diagonals are perpendicular, so they meet at a right angle. And bisect the angles, the opposite angles. So this angle is congruent to this angle is congruent to this angle, and same on the other side. It doesn't say all those angles are equal, does it?
No.
Okay, but that means that Q is congruent to what?
Q is congruent to
S. And that means that P is congruent to?
P is congruent to R.
To R. Okay? So, and all the sides are congruent. A rectangle. If a parallelogram is a rectangle, then the diagonals are congruent. You also know that the opposite sides are what? Congruent. And you also know that all four complete angles are right angles. Well, this is a transversal, yes?
Yeah.
So does that mean this is congruent to this?
Yes.
And does it mean this is congruent to that?
Yeah.
In the same way on the other one?
Uh-huh.
Okay. A square. If a parallelogram is a square, the properties of both the rhombus and the rectangle apply. So the diagonals meet at perpendicular, they bisect each other, all sides are congruent, all the angles are right angles. So the question that everybody asks, or they say, or whatever, are all squares rectangles?
No.
Yes.
Yes, because the properties have to apply, right? Are all squares rhombus? Yes. But are all rhombus squares?
No.
Nope. Are all rectangles squares? No. Since both the rectangle and the rhombus properties apply, I could classify a square as both, but I'm not going to, am I? But I could. So, rhombus. What is measure of RPS? So, RPS is right. RPS is right here. Yes? Okay. So, what do I know about this thing? What do I know S is? 70. How am I going to figure out the other two angles?
Add them and subtract 5.
Take 170 minus
180 minus 70.
Okay.
Because there's 2 triangles.
Divide by
Okay. Exactly. Because what kind of a triangle do I have here? No. An isosceles, yes?
Yes.
And aren't my base angles equal? So if I take 180 minus 70, I get 110. But what do I know about both of these angles? They're equal.
So you have to divide.
So I have to divide by 2. So I get 55.
Yeah.
So angle RPS is 55. Anybody else want to do it differently?
No.
What if I did 360 minus 170, 140
How would you do that?
divided by 4? What do all the angles in a quadrilateral add up to be? 360, yes?
Because 70 plus 71 plus
70 plus 70 is 140. And aren't every single one of these little angles the same? Yeah? And so I divided it by 4, and I still get what?
55.
55. So are there more than one way to do it?
Yes.
Yes. Is there a more efficient way than the other?
Yes.
Yes. Okay. We still have a rhombus. What is MNO? So MNO, we're talking about
Not triangle.
this whole angle, right? So I know this is 62, so I also know this is what?
62.
What do I know this one is?
90.
90, because their diagonals meet at a 90 degree angle. So can I find the little angle?
What's 62 plus 62?
Well, couldn't I just do 90 minus 62? So it's 828. Is that right? 90 minus 62. Okay, so that's 28. So the little angle is 28. How do I get the big angle?
You add them both together.
Add them together or multiply by 2. So the measure of MNO is 2 times 28, which is 56 degrees. So have you done these things before?
Yes.
Yes, it's just like a bigger puzzle, right? Questions.
No.
So guess what? The next example are
Is this all it is?
squares. Yes. Okay. It says find find the measure of angle MPZ.
We're not on yet.
Yeah, we don't
We're
know.
on.
What is QT? We don't even have that.
No, that's the last one.
It's the last one.
That's the last one?
Oh, it is the last one.
Okay, just go to the last one then. We'll do it out of order. Or do you want me to go to your order?
No, it's fine.
It's fine.
Okay,
But you're just.
I know. You said it's fine. Which one do you want to do first?
This one.
Okay, we're here. So we want the measure of YPZ. So YPZ. That's right here.
Uh-huh.
And I touched it.
Oh my god.
Oh, just stop it. Stop it, stop it, stop it. I'm going to make you sick. Right here, yes?
Yeah.
Well, it's a square. What's that angle?
90.
It's 90. Because they meet at what kind of angles?
Right.
Right angles. So now it says XWP. XWP. So that's this angle, yes?
Yeah, same thing.
I would
It's
agree.
not a right angle.
The whole thing is what?
360.
No, the whole thing is 90.
Oh,
What's half of it?
45.
45. So it's 90 divided by 2.
45.
So 45 degrees. Are we going too fast for anybody?
No.
And what is XZ? So XZ is the whole thing, yes? And if this piece is 7, this piece is 7. So 2 times 7, so 14. Pretty easy, huh?
Yeah, it is.
Okay, now we'll go to I don't even know why they're all out of order. I need to fix
Today's not your day.
I know, it is just not. Okay, here's a rhombus again. So we're back to rhombus. I want QT. So I'm looking for just here, right? And I have QS, yes? How am I going to do that?
Find the whole-
Well, I know,
Send them
first
close
of
to
all,
each other.
just a second. I know QS. I'm sorry. I know QT is equal to QS divided by 2, don't I? Okay. So I need to find QS, but I can't find QS till I find what?
QT. Or
Till Y. So how am I going to find Y?
send them equal to each
So what equal to each other?
other. 5y and 3y.
The 5Y minus 4 I can't do anything with.
That's the.
That's the whole thing, but I can't, that's not going to help me solve this.
So then the other two.
What do I know about these two sides? They're congruent, yes?
Yes.
So if they're congruent, I set them equal. And will that help me find Y?
Yes.
Yes. You had one in your homework yesterday that you had to find something else to use, right? So, let's see, subtract 2Y. Add 1. So Y equals
16.
16.
That's the answer.
I got 4.
Why
Well, I mean,
four?
the
Well,
whole
Y
answer.
equals 4, yes?
Yes.
So now up here, I need to plug 4 into Y. So 5 times 4
20.
minus 4 over 2. So 20 minus 4 is, so 16 divided by 2 is
8.
8. So QT equals
8.
8. So are you going to have to find one thing to find another?
Yeah.
Yes. So we have one more example, rectangle.
Yeah.
Okay, rectangle. So it says find MP. So MP. What do I know about rectangles, diagonals? They're congruent, yes?
Yeah.
So if I know this chunk right here is 5, what's the whole thing?
10.
10. Well, MP is congruent to NQ, yes? Which is equal to what? 2 times 5 or 10.
Oh.
You see how I worked backwards there? Okay. So let's see if you guys can find MQ. I bet you can't. Because I bet you won't see it. I'll help you. Okay, do you see this triangle right here? And you haven't outlined it yet. See that triangle right there? Is that a right triangle?
Yes.
Yep. And one, so I have a triangle that looks like this, yes? And this is 4. And this is 10. Yes? And what do I have that solves right triangles? What? The Pythagorean theorem that says a squared plus b squared equals c squared. C is always the what?
Longest.
The longest, the hypotenuse. Yes?
So 6.
Does it matter what A and B are?
No.
No. So I'm going to subtract over one of them. So I get A squared equals C squared minus B squared.
Yeah.
Okay, so how do I get rid of the squared? Take the
So,
square root. So I get A equals the square root of C squared minus B squared. I told you the Pythagorean theorem never goes away. Okay, so let's fill it in.
what?
Get
Well, what's C?
I got it right all
10.
10. So 10 squared minus, what's B?
4.
4. Yeah? So I get 100 minus 16. Pretty sure that's 84. The way my day's been going, I could be wrong. And 84 is not a perfect square. Shoot. So I need to reduce this, yes? So does 4 go into 84?
Yeah.
Yeah. Is 4 a perfect square? Yeah. So I can start there, right? So 4 goes into 8 twice, and it goes into 4 once. Is 21 have any perfect squares in it? What's 21? What times what?
7.
7 times 3. So is there anything good in that?
No.
Nope. So I have the square root of 4 and the square root of 21. What's the square root of 4? 2.
Yeah.
And the square root of 21 stays the square root of 21. So MQ equals 2 square root of 21.
Yeah, I would have never figured that out.
So our right triangle is going to pop up from time to time. Yes, we're actually going to have a whole trig unit. You cannot forget the Pythagorean theorem. If you don't have it written down on your paper, write it down. You will always have right triangles popping up in almost every single math class you have from here on out. And you have to remember that you can use what to solve them? Pythagorean theorem. And that is done.